How do you rationalize a denominator? You ask it to be reasonable instead of irrational. Get it? Anyways, you'll be learning later in this lesson how to rationalize denominators. So the first part is we're going to be looking at special triangles. And where do special triangles come from? Well, they come from a couple of different regular polygons. For example, I have square ABCD on the right. And what I'd like you to do on your notes is draw a diagonal from point A to point C. And then we're going to go ahead and shade in triangle ABC. The question I have for you is, which leg is bigger, AB or BC? Well, this is supposed to be a square, which it does say in your notes. It doesn't say it right here. This is a square. If it's a square, then those sides better be congruent. And which leg would be bigger? Well, neither one. They're both congruent. So if I just look at the yellow triangle here, what kind of triangle is it? Well, there are two things. It is an isosceles triangle, but it's also a right triangle because the corner of that square is a 90-degree angle. So I know that the measure of angle B is 90 degrees. CAB and ACB, this is isosceles, and so these two angles have to be the same. So hopefully you'll know that that is 45 degrees for both of those. If not, you could write x plus 90 equals 180 and solve for x. So what we're going to do right now is find the hypotenuse for these 45, 45, 90-degree triangles. Well, if I know one leg, then I know the other. So I know one of the legs. If you remember, let me go back to my drawing. I'm looking at leg AB, which is on bottom here, and leg BC. All right. So if AB is 1, BC is 1. If AB is 2, BC is 2. If AB is 5, BC is 5. If AB is 10, BC is 10. If AB is n, standing for any random number, then BC is n. Now let's go ahead and find the hypotenuse for each of these triangles. Well, I've got a square. Since it's the same leg, it's 1 squared plus 1 squared, which is 2. Then take the square root of 2, and I use my calculator. And I got 1.414. All right. Doing the same thing for when the leg is 2. 2 squared plus 2 squared, that's 4 plus 4, that's 8. Square root of 8, and that's what I get from my calculator. Do the same thing here. 5 squared plus 5 squared, that's 25 plus 25 is 50. And I get a square root of 50 as my answer. And I keep going, and I get square root of 200 as my answer. So the question is, what kind of pattern, and actually I can still do n squared plus n squared, I'm going to get 2n squared. And that kind of fits the pattern here. You see how you take this, square it, and double it. So that's the pattern we're getting for the hypotenuse squared. Now, one thing you might notice is if you look at how it jumps from here to here, it jumps by 1.414. And then if you look at when I do 10 of them, it's like 10 times 1.414. So we're going to make the conjecture that the hypotenuse, if the side is n, we're going to say it's 1.414. Okay, where is 1.414 coming from? Well, you can probably see that square root of 2 is 1.414. So we'll look at two of the triangles. One, we have the original reference, which is the 1, 1, and I can find my hypotenuse, which is square root of 2. All right. I can do the same thing for the general case. So I have n, and I'm trying to find the hypotenuse, so I go n squared plus n squared is c squared. And you saw that. We had that 2n squared in the table. Here's the tricky part. I'm going to take the square root. Well, I can break that up into the square root of 2 times the square root of n squared, which is square root of 2 times n. So that gives me the hypotenuse there. And if you look at your math chart, that looks a lot like your math chart, except they're n's instead of x's. I don't really like the x's on math charts because a lot of times, out of habit, we tell you look for x, but we may not be referring to what x is on the math chart. So the 45, 45, 90 triangle theorem says that if both legs are congruent, then basically the length of the hypotenuse is the length of the leg times square root of 2. Also, one other thing, we're going to have a lot of square root answers. So I really prefer exact answers over approximate answers. What does that mean? Anything you punch in your calculator where you have any sorts of decimals and there was a square root, you are approximating. Even if you use every digit on that display. You don't want me to ask you to write down the entire decimal answer because it never ends. Square roots are irrational numbers, which means that if you try to write them in decimal form, they will go on forever and they won't even repeat. All right, so if you leave the square root in the answer instead of rounding, that's my preferred, then the answer is exact. All right, so in most of the work I'll do tonight, you can see that I leave the square root on there. So for further reflection, how did we make a 45, 45, 90 triangle? What shape did we start with? Where does 1.414 come from? And how did we deductively prove the 45, 45, 90 triangle theorem? Remember, I did the general case with n, and that really helped to show